The Rabin-Miller Primality Test is a widely used test for determining whether a number is prime or composite. This video will go over the history of the test, the concepts that allow it to function, and some examples.
The name of the test comes from two renowned computer scientists and mathematicians, Gary L. Miller and Michael O. Rabin. Miller presented an early test based off the extended Riemann hypothesis in his paper Riemann's Hypothesis and Tests for Primality in 1976. Rabin built off the concepts that Miller discovered and published his findings and the algorithm as we use it today in 1980 with the title Probabilistic Algorithm for Testing Primality. Miller's test used a generalized Riemann hypothesis to prove its efficacy, but Rabin realized that he could write a better primality test with the same underlying concepts. Rabin's test today does not require the assumption of the GRH, but if the hypothesis is assumed, it can be shown that its test runs in polynomial time.
These tests probably seem counterintuitive at first, but the concepts that they arise from are really very simple. The first is that if x squared is congruent to 1 mod p, where p is prime, x must be either positive or negative 1. Fermat's little theorem tells us that if n is prime, a to the n minus 1 is congruent to 1 mod n, which means that all the square roots of a to the n minus 1 must be plus or minus 1. This is the reason that we factor n minus 1 into an odd integer and 2's. The two tests come from this idea. If a to the q is 1, all the subsequent squares, including a to the 2 to the k times q, which is a to the n minus 1, will be 1, and n base a satisfies FLT and passes the test. If a to the q is not equal to 1, but some a to the 2 to the s times q equals negative 1, all subsequent squares are 1, and n still passes. We don't check if it equals 1 since the first test failed, which ensures that this is the only way for FLT to still hold true. If neither test passes, a to the n minus 1 is not equal to 1 mod n, and therefore n must be composite.
Also known as absolute Fermat pseudoprimes, Carmichael numbers are named after American mathematician Robert Daniel Carmichael, who in 1910 discovered a series of composite numbers that passed Fermat's little theorem. A to the n minus 1 is congruent to 1 mod n for all a relatively prime to n, even though previously it was thought that only prime numbers n could satisfy this theorem. The first instance he found was 561, which is 3 times 11 times 17. Since 561 is a Carmichael number, all numbers coprime to it raised to the 560th power modulo 561 will equal 1, yet clearly 561 is known to be composite. For example, 2 to the 560th power is congruent to 1 mod 561, 19 to the 560th power is congruent to 1, and so on and so forth. He later went on to develop an algorithm to compute all possible Carmichael numbers.
We hope now that you know more about the history and the concepts that allow it to function, you can understand the Rabin-Miller Primality Test a little better. Underneath it all, the math involved is much simpler than it looks.